Here we go. All right, the rest of chapter 3. You probably don't know who Paul Harvey is. He used to say, now you know the rest of the story. So I'm going to put this up and I'm going to come over here. And chapter 3, we've been working with if statements. Next week, chapter 4, we're going to start with something called looping. And it's taking multiple lines of code and going. You already know 2-point question on the test. Whoop, there it is. What are the relational operators? 1, 2, 3, 4, 5, 6 of them. What do? They compare expressions. The result is Boolean. Told you that's going to be a 4-point question right there. Boom. Where do we? Well, that'll be easy for me to say. Where do we use these? We use these in to create a Boolean, and where we're using them right now is this if x is less than or equal to 6 type of deal. I have a Boolean statement if this is going to depend on being true or false. Okay. We're now going to look at another group of operators. We did have the assignment operator. That was just this. And we cautioned this is different than the equals. Okay. We have the assignment operator. We have the relational operators. We had algebraic operators, plus, minus, times. Now we're looking at something called the logical operators. Some of you may have had this in math classes somewhere along the line, but this is logical operators. And what these are going to do is compare Boolean. That means on the left side, there's something Boolean. On the right side, there's something Boolean. And it's going to give me a result. We have 3 of them. And, oh, aren't they pretty? And, which is this double ampersand or treble clef. Is this a treble clef? Anybody music people? Is that what that's called?
Looks like it.
Yeah, okay. Thank you. I wasn't played trombone in 5th grade, but that's as far as I got. So that's to represent this word and. We have 2 straight bars side by side, no space between them, representing R, and the exclamation point representing the not or the opposite. Not kind of is going to be, I'm going to throw in the word opposite right there. I don't know if you can see it. Okay, so let's take a look at a left side and a right and how some of this works. So we're going to take a look at X, and I'm giving it values true, true, false, false, because in order to get all possibilities, I kind of come up with a pattern. So now I have a true and a true, true and a false, false and a true, false and a false. Came up with a pattern. If you take CPS 230 with me, we get into a whole bunch of Boolean algebra. We expand this and we get a deeper look at how it really comes into play in computer science. All right, so these are truth tables. If I had a logic course in grad school, and it was if I win $1 million, I will give you 100,000. And it's one of those where each one of these, if you thought of them as statement, logically works out. A lot of you have seen this already, but if the left side is true and the right side is true, this evaluates out to be true. What the heck are you talking about? Well, let's take a look at a quick example. X equals 4, y equals 5. If I have a statement that looks like this, where on the left side, I'm going to say if x equals 4 and y is greater than 2, yada yada, else yada yada. Okay. This guy, yep, x equals 4, that evaluates out as true. Y is greater than 2, that evaluates out as true. So if this is true and this is true, I will execute the next couple of statements based on this idea of truth tables. So this is an example. This is a logical operator. It compares booleans, and the result is boolean. Okay. Filling out the table. This is the only time it's good. Was true. Life is good. This is not good. This is not good. And this is not good. And we're only looking at 3 logical operators. There are others, a bunch other. Does anyone know anything about or?
One of them has to be true.
Yep, one or the other. So if I take true or true, it's true. True or false is true. False or true is true. False or false, womp, womp, womp. These are no good. Okay. Finally, not is the opposite. So if this is true, this now becomes false. If this is false, it now becomes true. This is the not of something. And you're going to see where we're going to throw not in front of a whole bunch of different type of things over the next couple of semesters if you for those who are comp sci majors. Okay, according to my notes, you typed in code listing 3.8 looks something like this. I come in and where we have something. Well, I enter a salary, and all of a sudden, if the salary is greater than $50,000 and years on the job equals is greater than or equal to 2, there you go. You qualify for the loan. So this is an or statement. So that means one of these two had to be true. Well, I make $20,000, but I've been on this job for 40 years, so I qualify for the loan. Cool. Over here's something. The order of precedence. We have not, and or. Well, there used to be another one called exclusive or. An exclusive or actually fit right in the middle, and it was not, and or. And when that fit in the middle, we put an X. And exclusive or is one or the other, but not both. But we don't get into that. Naxo was the way we used to remember the order of operations. But the not, as always, we have this order for operations. I like it. I love it. I want some more of it. So if I look in my book, in 1 second here, I need to get Mr. Eraser out. And why is that erasing Goofy? Chinka ching ching. Oh my goodness. Somebody wrote in my book, and I think it was me. Boom. Boom. As we go through, you're going to find out more and more. False and 0 go together. True and 1 go together. My buddies and I, we go to trivia on Thursday nights most weeks. And if it's a true false question, instead of saying the answer out loud so people can't hear us, the nerds go 0 or 1. So I'll look around and everybody thinks it's false or everybody thinks it's true. Kind of geeky, but it's 0 or 1. The whole world is 0 or 1. Looks something like that. You've seen it all over the place. Your on off button on your computer. A lot of them have this light switches. They're everywhere, but it's that 0 and 1. That's not the same as this because we all know what this is, right? What's that? Where's my Harry Potter peeps? Cloak of Invisibility, the Resurrection Stone, and the Elder Wand. Nobody? Can I get a thumbs up? Anybody? Nobody. Am I the only one that likes Harry Potter?
That was good. It's just too early.
Oh, it's too early. Gotcha. So I should be talking a little slower then, as long as I don't talk like this. All right, rip through this column. Trying to remember from what we just talked about a minute ago.
The first one is true.
First one is uh no, this is and. First one's going to be
Oh
false.
yeah, true equals true.
Yeah, this one's going to be true.
For third one is false.
Yep, good.
False.
Yep, you're on a
Uh,
roll.
true.
Yep,
True.
yep.
False. I'm true. True. Yeah.
Yeah, this is true. Then the last one would be false. And of course, these are the opposites. Bada boom and bada boom. Good. Just a quick little mental practice. See if you can remember them. Down here, number 17. There's a lot of good stuff in this book, by the way. 17. 17. Number 17. If A equals 4, which is false, B is greater than 2, which is true. This is an or statement, so that's going to be true. Number
Uh,
2.
false. I guess.
Number 2 is false.
Yeah.
Can I get a hell yeah from a redneck girl? Is C greater than or equal to 6? That's true. And is A, so this is true, and A is greater than 3. That's false. That makes this false. Is 1 not equal to B? That's true. C not equal to 3? That's true. So this is true.
True.
We got a true for this one. Let's see. A is greater than equal to -1. That's true. Or, well, heck, I can stop right there. Since this is an or and this left side is true, I already know the answer is going to be true. A is, in fact, less than B. Okay. Is A greater than 2? Nope. The opposite of that is yep. So this becomes a true. Any questions? Any questions? Any questions? The logical operators. Okay. And, we have a whole bunch of notes and everything going on here. We covered all of that. And we may come back to this and we'll talk about this later. Do, 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 do. Say. Okay, I want to make sure we get everything done first. All right. Section 3.6. We're going to go back to strings. And if you remember, we created we created a variable string, name one. And we learned about a couple of these things called methods that do some work on a string. This ch3 said, take the character at position 0. This one, dot length, gave me the length of the string. These are on the test. Ch3 and length. Please don't dismiss them so easily. String name 1 equals Mark. String name 2 equals that. What if I said, hey, I want to know if Mark is equal to Mary? This is not how we do it. So if you remember, when we created a variable that was a string, like name 1, what was stored there is an address. Over here at the address, we have MARK stored. Name 2 is an address. It tells me where Mary is stored. So when I do this statement, if name 1 is equal to name 2, I'm comparing these two addresses to see if they're the same. So this is no good. In Java, this, unless I want to check the addresses, which I have never done in 40 years. But if I want to compare addresses, this is how I would do it. If I want to compare what's at the addresses, I'm going to use this thing called dot equals. Just like these two methods, here's another method. I want to know if name one is equal to name two. And we'll get into the syntax of this later, how all this really works and why that's over there in parentheses and this one's here. But for now, you're just going to follow the syntax. This is how I check to see if two strings are in fact equal. And should be somewhat familiar because there's Mark, there's Mary, and we're having a good time in here. And we come in and say, here's an example of it. If name one dot equals name two, yes, those two are the same. If name one dot equals name three, they're not the same. So again, I'm using my if statement and I have a Boolean coming out of this. This is going to be true or false. That's a bunch of Boolean. It's too early. It's too. You also did 310. And here's another method. It's called compare to. I still like dot equals. But this method compared to, hopefully when you typed it in, realize three possible things could happen. If the first one is less than, that means Mark came before Mary. This would happen. If they're the same, compare to returns a zero. And if it's the other way around, I get a positive number. We almost never use compare to, but it's there. Dot equals is much nicer. Nicer like you, Professor. I know. Thank you. Well, I better be careful. This is being recorded. Okay, here's a quick hitter. Section 3.8. Section 3.8. We have this new operator. It's this question mark, and it does some crazy stuff. This is called a conditional operator. If you look in our book, you'll see that it's listed as optional. I throw it in there. And the reason is I go to Kansas City every year in June, and I grade high school AP Java tests. And 50% of the students use this conditional operator. Now, how's it work? Well, we come over on the other side of our assignment operator. If this is true, it goes and does y gets a value of 10. If this is false, it skips over and it'll let y have the value of 20. So this one line can replace if x is less than 0, y is 10, else y equals 20. So just a quickie there. Throw it out. Use it if you want. It's easy to mess up the syntax because this just flows a lot easier. But whoop, there it is. I said, where is? Okay, moving on. Section 3.9, we have a switch statement. This is like an advanced if statement. Like it's an if statement on a higher level. Okay. So we come in and, oh, my handwriting's a little atrocious. I don't know why, but it's bad. Let's see what we got. In fact, let's get out of here and we're going to look at the book example because that's just awful. So I have this thing called a switch statement, and the switch is on based on this guy right here. Basically, what we're saying is if number equals 1, do this. If number equals 2, do this. And all the way down. And if it's not a 1 and it's not a 2, then we hit the default. So what do we have? This case selector is kind of an ordinal value. An ordinal value has something that comes before it, a unique successor, and a unique predecessor. For example, if I said 6, what comes before 6? Shout it out.
Five,
5. What comes after 6?
seven,
Good. What comes before the character A or B? Duh, A. What comes after B? Yeah. What comes before true?
false,
Yeah, absolutely. What comes after true? It's also false. It wraps around. Okay, it's like circuit. What comes before 4.16? We don't know. We don't know if it's 4.15, 4.1599999. We have no idea. So we can't really use these so much up here. All right. Can be a string. I can put a variable up there. It can be a string and so forth. So when you were doing this, you had 3 code listings, and one of the big concerns was be careful of the break statement. So let's see what you did. You did 313. Do, 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 do. Here it is. We come in, and if the number equals 1, we put you entered 1. We hit this thing called a break statement that says get out. This break statement is going to take me down and out of the switch. It's going to take me to the end. So if it's a 1, it does this and out. If it's a 2, it does this and out. A 3, if none of those, it will hit this one. Nice, solid starting example. Now, hopefully, when you typed in this code listing, you saw where the problem was. We come in and, oh, we're happy. We enter a 1. Number 1 equals 1. So I hit this line. Guess what? I don't have the break to get me down here. So it doesn't matter this or not. If it's a 1, it's going to do line 23, 24, 25. Boom, boom. It's still going. It's still going. Heck, it's going to print out all 4 of those statements. The reason is the break is missing to get me out of here. Get me out of here. I'm in a box. Code listings are making good sense. Another example. And again, the more you type in these code listings, the better you're getting at Java, believe it or not. Muscle memorization. We come in, and if it's an A, I hit line 28, I hit line 29, I hit line 30, and then I finally break. So if it's a little a, just keeps going till it hits the break. If it's capital A, it hits this and it hits a break. So this way I can check for an A or an A. This kind of replaces the statement that might look like this. If food grade equals little a, or food grade equals big A. Oh, star, here come a star. Questions on the switch statement. Good. Boom, 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 boom. Boom, 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 boom. Finally, 310. The last section. We're formatting. Da, 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 da. So I'm going to go load up that file for 1 second. Okay, I'm now going to share my screen. It's the file that I was talking about earlier that can be downloaded from D2L. And we're going to take a look at this. It's a good file to have to hang on to. All right, blah, blah, blah. Name, date. Some of you aren't putting this in your program. You're killing me. You're killing me. You'll see someday where this is advantageous. Line 9. Oh, I have a new import statement. Line 10. You're using this in all of your programs. We're using J option pane class. Decimal format. I come in. I have string, one for input and one for output. Not the best names. some languages won't let you use the word input or output. Instra, outstra works pretty good. So what do we have here first? I have something called, and you'll see what's going on. I have something called decimal formatter. Okay. Read line 20. The book used to include this method of formatting. Not sure why they took it out. So for this program, I need line 10 up above, or excuse me, 9 for that decimal format. I have 23. Now, when I look at 23, I'm going, okay, what do I got there? What happens with 23 is it's set up so that when I go down to line 30 and print something out, like in this case, num1, it's going to follow this format. If it has thousands, right? If it's over like 4,000, the asterisk says, or excuse me, the pound sign says print the 4 and the comma. Print the 4 and a comma. If it's only like the number 20, it will skip pound, 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 except it'll put a 2 there and a 0. So the zeros mean something's going to be required in the output. The pounds are if needed. The pounds are if needed. So if I run this program, and if you haven't run it, and you start typing in a couple of things, you can see where this decimal format's going to help you. So this is the an old way that the book used to have. If I come down to line 36, I see what the book has now. This says blah, 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 blah. Here's your number again. Okay. This time it does a percent sign. What the percent, what this does is says, I want to format a float, which is num1, with 2 decimal places and a comma if needed. So you don't really need to get into the syntax. You just need to know that this will format to 2 decimal places. And again, this is all included in one statement, stores it in output, and displays it. This one, 40 and 42, is much simpler to use. Okay? Good? All right, that's why I gave you a little extra time on 3.1 in case you needed to go and grab this and use it. But we've now officially covered it. So at this point, we've covered everything that we needed for test number 1. I'm going to ask you, are there any questions? Bring it on. Okay, bring it on. All right, coming over here. Let's take a look at this guy first. Shipping charges, number 9. Number 9, number 9. Can you make an algorithm for this? Can you? Well, yeah, I can. So let's see. The freight of a company charges the following rates. The shipping charges, blah, 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 blah. Write a program that asks the user to enter the weight of a package and displays the shipping charge. Okay. It looks like, the shipping charges per 500 miles are not prorated. For example, if a 2-pound package is shipped 550 miles, the charge is $2.20. So every 500 miles, it becomes this. Wait. I'm going to need some test data. I need to figure this out. Okay? So, for example, if I said 2 pounds or less. So if the weight is one, if the weight is one, it's going to hit this, but I'm going to have to also input something else, aren't I?
Miles.
Yeah, I'm going to have to input the miles. So if the weight is one and the miles is 50, my cost, if the rate is one and the miles is 50, my cost is $1.10. Sound right?
Yeah.
Okay. So what if my weight was one and the miles was 550? What would the cost be?
Two something. It'd be
Yeah,
more than
220. If my
20.
weight was one and my miles was 1,503,
3.30.
not three, actually 4.40.
40.
Yeah. Yep. So I have something going on there that I have to figure out. After that, I start to check. Um, let's see if it's over 10 pounds, but not more than so over 10 pounds. So if I said the weight is 10.1 pounds and the miles is 1,000, this should be doubled. This should be 760. Okay. I can't do the program until I get this stuff kind of straight. I got it straight a little bit. All right. So what am I going to do? I'm going to, first of all, if I need to check the weight, depending on what the weight is, this is going to be the cost. Okay. Once I have that done, then I'm going to check the miles and see if I need to multiply this. Make sense? So if I'm writing an algorithm, I'm going to input, first thing I need to do is input weight. If weight is 2 pounds or less than or equal to 2 pounds, I want to do, let's see, what do I have? My rate equals $1.10. Okay, all right. Else, if weight, let's see, is greater than two, what would go next?
220.
Yep, I need an and sign because I'm looking at if over 2 pounds, but not more than six. So if weight is less than two and weight is less than or equal to six, now I have a rate of 220. So I'm going to keep going with that to come up with some sort of an algorithm. I have a couple of more, another if then, and then it looks like an else for my default. Okay. So after all of this, I'm coming up. So I got to input weight. Good. I have this block of code, and I'm just going to do this because I can do whatever I want. And now I have a rate coming out of here. Now I need this multiplier. So I'm going to input miles. And then depending on what miles does, I'm going to multiply that by the rate. So let's see. I'm going to try to come up with something. If miles is 0, I multiply it by 1. All the way up to, it looks like 499 miles. If miles is 500, all the way up to 999, I'm going to multiply it by 2. Oh boy. If it's 1,000 all the way up to 14.99, I multiply it by 3. Hmm. Hmm. So I input miles. Now I have some more work to do. And eventually I'm going to say shipping charge equals what came out of here? Rate times some kind of multiplier. That's my final answer. How do I get that multiplier? That's in here. I need to figure out a way to make this work. Okay. Multiplier is 2. Multiplier is 1. Multiplier is 3. Let's just assume no miles over 1,500. I'm going to keep it somewhat easy. So now you need to put this, now that I've used test data, I'm building my algorithm. We already looked at how this is built. We're going to do something similar here. Then the shipping charge is going to be the rate times the multiplier. Questions?